Hello students, welcome back to our channel. After a long time I am back with most fundamental and basic topic, that is metals and non-metals. So from your school level to college level, so each and every year you have metals and non-metals topic in your chemistry. So listen all of you, this is the basic and fundamental topic. So if you have a good knowledge in these metals and non-metals, so the remaining syllabus of the chemistry will you feel very easy for you. So before going into the topic, I just ask you one question. As of now, how many elements in our nature? How many elements we have in our nature? So that we have 118 elements. So among those 118 elements, 94 are naturally occurred elements, and the remaining elements, that means 95 to 118 elements, are man-made elements or synthetic elements. That means the elements which are produced in the laboratory is called man-made or synthetic elements. Okay, so from 118 among 118 elements, 94 are naturally occurred, and the remaining 95 to 118 are synthetic elements. So among these 118 elements, how we differentiate metals and non-metals? By using the periodic table. So already you know about the periodic table, so that I just have to draw a basic skeletal structure of periodic table. This is the skeletal structure of periodic table. So in this periodic table, we have from left side to middle part we have metals, and from right side we have non-metals. All of you know this. From left side we have left side to middle part metals, and right side to non-metals. So how, on which basis we classified them, metals and non-metals? By using their physical and chemical properties. Okay, so by using physical, chemical and physical properties, some elements exhibits some type of properties, and some elements exhibit some type of properties. Basing on their properties, we classified them metals, and we classified some elements are non-metals. That means, so same type of properties exhibited by some elements are placed in placed at one place, and the remaining elements are placed at one place in the periodic table, so that we have some metals and some non-metals and some metalloids among these 118 elements. So by using the periodic table, so do you know about the definition of periodic modern periodic table? So the physical and chemical properties of elements are the periodic functions of their atomic numbers. This is the basic definition of modern periodic table, modern periodic law. Okay, this is the just introduction part, how we classified metals and non-metals. Next, coming to the point, coming to the actual topic. First, metals. First, we will take metals. So, what is the definition of metals? Metals are the elements which have the capacity to lose electrons, are called metals. Any element, if you take any elements which have the capacity to lose electrons during a chemical reaction, are called metals. Some elements have the capacity to lose, only to lose electrons, and some elements have the capacity only to gain electrons. So basing on their losing and gaining of electrons, we can classify them, some are metals and some are non-metals. Okay, so this is the definition part of metals. And how many metals we have? We have 91 metals. Among those 118 elements, we have 91 metals, and we placed from left to middle part in the periodic table. We placed metals from left to middle part in the periodic table, and the examples of metals are sodium, iron, aluminum, copper, silver, etc. Next, coming to the non-metals. Non-metals are quite opposite to the metals. So, definition part of non-metals are an element which have the capacity to gain electrons during the chemical reaction. While during the chemical reaction, it's called the non-metals. So how many non-metals we have? We have nearly 17 non-metals. Among those 118 elements, we have 17 non-metal elements, and we place it in the right side of the periodic table. All the non-metals are present in the right side of the periodic table, and the examples are hydrogen, oxygen, phosphorus, and sulfur. So here are some more elements are present. So those are called metalloids. Why we call them as metalloids? Only few elements are metalloids. So why we call them as metalloids? because some elements exhibits both physical and chemical properties of metals and non-metals. Those elements are called metalloids. Only we have 7 metalloids among those 118 elements. So guys, this is about just introduction and definition parts of metals, non-metals and metalloids. So now in this class I am just only tell you just metals and non-metals. This is about the definition part. Next, coming to the physical and chemical properties. Uh, by observing their physical and chemical properties, mostly all the elements are classified into metals and non-metals. So before going into the physical and chemical properties of metals and non-metals, what is meant by physical property and what is meant by chemical property? So what is physical property? Physical property or physical change is a change in a substance which we can feel, which we can observe with our eyes, which we can sense, which we can smell, okay, without change in their chemical composition. Without change in their chemical composition is called physical property. So in this physical property we don't have any new compounds, just we observe the external changes only. So the exact definition is the change in a substance which we can feel or we can observe or we can sense with their without changing their chemical composition is called physical properties. The change in a substance which we can feel, we can observe, we can sense or without change their chemical composition is called physical properties. For example, ice converted into water. This is the most important physical property. So now I am just going to tell you some physical properties of metals and non-metals, so that I just draw a table rough tabular form so that you can understand very easily both the physical and chemical properties and sorry both physical properties of metals and non-metals. So first physical property of metals. First one is metals are hard in nature. Metals are hard in nature. For example, iron, copper, silver, gold. These are under the examples of metals. Next, coming to the non-metals. Non-metals are soft in nature and also gaseous in nature. Non-metals are soft and gaseous in nature. These are not hard in nature, non-metals. For example, chlorine, sulfur, phosphorus. These are the examples of non-metals. Okay, this is the first physical properties of metals and non-metals. Next, coming to the second physical properties. Metal shows malleability nature. Metals exhibits malleability nature. Malleability means what? Malleability means making of metals into thin sheets by applying some external pressure. Without applying any pressure, there is not changing into one form into another form. Na? Okay, making of metals into thin sheets with applying some external pressure is called the malleability property. Metals exhibits malleable property, but non-metals does not exhibits malleability property. Why? Because these are soft and gaseous in nature. So for example, iron is the metal, we have iron sheets. Okay, copper is the metal, we have copper sheets. Aluminum is the metal, we have aluminum sheets. Like that, these are the examples of malleable property of metals. Next, coming to the third physical property of metals. Metals also exhibit ductile in nature. Metals also exhibits ductile in nature. Please write down all the points in your notebook. So these are very very important. Please try to write down the points in your notebook. Third property is these are metals are ductile in nature, whereas non-metals are not ductile in nature. What is meant by ductility? Ductility means making of metals into thin wires. Malleability means making of metals into thin sheets. Ductility means making of metals into thin wires. For example, copper wires, iron wires, gold wires. Okay. So these are the examples of ductility. Next, coming to the fourth physical property of metal. Metals shows lustrous property, whereas non-metals does not shows lustrous property. Lustrous property means what? Lustrous means shining property. Lustrous means shining property. For example, gold is a shiny metal, isn't it? Silver is a shiny metal. Copper is a shiny metal. Iron also is a shiny metal. So these are the examples of lustrous property of metals. So non-metals does not show lustrous property because these are soft and gases in nature. This is the fourth physical property. And next coming to the fifth physical property of metals and non-metals. So metals are good conductors of heat and electricity. Metals are good conductors of heat and electricity, whereas non-metals are bad conductors of heat and electricity. Why? Because metals are hard in nature, so the electricity and heat passes very easily due to less intermolecular forces between the atoms in metals. Okay, so for example, iron, copper, these are the examples of good conductors of heat and electricity. Next, sixth physical property is metals have high melting and boiling point. Due to hard nature in metals, they have high melting and boiling point. What is melting point? Melting point means at a temperature where the metals dissolves into liquids. The temperature is called that melting point. Boiling point means where the liquids converted into gases at a particular temperature is called the boiling point. So non-metals have low melting and boiling point. Next, coming to the seventh property, metals produces cations, non-metals produces anions. These are the seven physical properties of both metals and non-metals. At least you have to write five physical properties of both metals and non-metals. So try to write the 5 points in your examination. Next, here are some exception elements are there. So which are metals but does not show any properties of any metal properties, or some are non-metals but does not shows any non-metal properties. So some few exception cases are: first one, mercury is a liquid. Mercury is actually metal, but metals are hard in nature. But here mercury is liquid and sodium and potassium are soft metals. Sodium and potassium are belongs to the first group. These are soft metals. Mostly first group elements are soft metals. Remember this point. Next, second exception point is lead and mercury are bad conductors of heat and electricity. Generally, metals are good conductors of heat and electricity, but here lead and mercury are bad conductors of heat and electricity. And the third point is metals are malleable in nature, but zinc is not malleable in nature. Okay, it is brittle in nature. Zinc element is brittle in nature. Next, fourth physical property is diamond and graphite are high melting and boiling point. Diamond and graphite are under the category of non-metals. So generally non-metals are low melting and boiling point, but here diamond and graphite are high melting and boiling point because these are hard non-metals. Because these two are hard non-metals, these are the allotropes of carbon. Next, fifth exception point is diamond is the hardest non-metal. Already I told just now, diamond is the hardest non-metal. This is the fifth exception point. Next, coming to the sixth point, graphite. Graphite is one of the non-metal. This is the allotropy of carbon. Actually, non-metals are bad conductors of heat and electricity, but here graphite is a good conductor of heat and electricity. So these are about the some exception cases of metals and non-metals. This is all about physical properties of metals and non-metals. Next, coming to the chemical properties of metals. We first initially we have to discuss about the chemical properties of metals, and next we have to discuss about the chemical properties of non-metals. First, chemical property. What is meant by chemical property? Chemical property means a change in a substance in their chemical composition and produce a new chemical compounds is called the chemical property or chemical change. The property of a substance or a change in the substance in their chemical composition and produce a new chemical compound during the chemical reaction. When? During the chemical reaction. During a reaction is called chemical property. So this is about the definition of chemical property. For example, raw food into cooked food. This is the chemical property and it is not reversible. Generally, physical properties are reversible, but chemical properties are irreversible. Next, coming to the topic chemical properties of metals. The first chemical property of metal is reaction of metals with oxygen. First chemical property reaction of metals with oxygen. When the metals reacts with oxygen to form metal oxides, metals reacts with oxygen to form metal oxides. Here is the one simple example. Magnesium is the metal. This is belongs to the second group. Metal magnesium reacts with oxygen to form magnesium oxide. So you have to balance each and every equation. Magnesium reacts with oxygen to form magnesium oxide. Okay, this is the simple example of reaction of metals with oxygen. So when the metals reacts with oxygen to form metal oxides and these are basic in nature. Another important point is all the metal oxides are basic in nature. Remember this point, all the metal oxides are basic in nature. Another example is iron reacts with oxygen and gives iron oxide. This is iron oxide is basic in nature. Next, second chemical property reaction of metals with water. Reaction of metals with water. When the metals reacts with water to give metal hydroxides and hydrogen gas. Metals reacts with water to give metal hydroxides and hydrogen gas. This is the basic chemical reaction. So here the example is sodium, potassium are highly violently reacts with water. Why? Because among all the metals, sodium and potassium are the most reactive metals. So later I will tell you the reactivity series of metals. So that is very important. So here sodium and potassium are violently reacts with water and produce some heat also. Okay, so metals are differently reacts with water. Some metals are differently reacts with water and some are reacts with differently. So here are the some few examples. Copper reacts slowly. Sodium and potassium reacts violently, but copper reacts with slowly with water. And iron reacts under the steam, not only water, under the steam. That means moisture conditions only iron reacts. And next, silver and copper are does not react with water. That's why we all are use silver and gold in jewelry makings. For example, sodium reacts with water to gives sodium hydroxide and hydrogen gas. This is the sodium hydroxide. This is the one example. Next, third chemical property of metals. Reaction of metals with acids. Reaction of metals with acids. So how many acids we have? Number of acids. So the basic most reactive acid is HCl. Do you know HCl is the most reactive acid? So next, metals reacts with acids to form hydrogen salts and hydrogen gas. So for example, sodium is the metal. It reacts with hydrogen chloride HCl to give salt NaCl and hydrogen gas. This is the basic example of reaction of metals with acid. Another example is zinc. Zinc belongs to the second group. Zinc reacts with hydrogen chloride. Sodium belongs to the first group and zinc belongs to the second group. Zinc reacts with hydrogen chloride to form zinc chloride. Zinc chloride only NaCl is not only NaCl is the salt. Okay, so zinc chloride is also the salt. Why? Metal zinc is the metal and reacts with acids. Always metals reacts with acids to produce salts. Okay, when the reaction takes place in between metals and acids, we have salts. We get salts. So potassium reacts with hydrogen chloride to form potassium chloride plus hydrogen gas. Next, fourth chemical property formation of positive ion. Already I told you in the introduction part and definition part. Formation of positive ion. When the metal loses an electron, to form a positive ion. This is the one of the chemical property of metals. Next, coming to the fifth chemical property, reaction of metals with bases. Reaction of metals with bases. Do you know when metals reacts with bases, which products are formed? Anyone of you? When metals are reacts with bases, which product is formed? Here, one important point is all the metals does not react with bases. Keep it in your mind. All the metals are does not react with bases. Only some metals, those are amphoteric metals. Some metals, some amphoteric metals only reacts with bases. Okay, so amphoteric metals means the metals which exhibits both acidic and basic nature, which have both acidic and basic nature, are called amphoteric metals. Aluminium, zinc, lead, these are under the category of amphoteric metals. So the reaction, for example, aluminium reacts with base NaOH. NaOH is a strong base. Aluminium reacts with base and have water to produce NaLOH4. Here NaLOH4 and hydrogen gas is liberated. So you have to balance this equation properly. This is the complex salt. NaLOH4 is the complex salt and the chemical name is sodium aluminate. And the next chemical property is displacement reaction of metals. This is the most important chemical reaction of metals. So before going into this reaction, we should have to know about the reactivity series of elements. So this is one of the most important series. So you definitely you have at least one question in your competitive exams. Okay, so you should know about the reactivity series of metals. So here I am going to write the reactivity series. The most reactive element is potassium, is most reactive than sodium. Sodium is more reactive than calcium. Calcium is more reactive than magnesium. Magnesium is more reactive than aluminum. Aluminum is more reactive than carbon. Carbon is more reactive than zinc. Zinc is more reactive than iron. And next, lead, copper, silver, gold, and platinum. This is the reactivity series. So from left to right, the reactivity decreases. Remember, from left to right, the reactivity decreases. If you So by basing on this reactivity series, uh, we can write displacement reactions very easily. So here, more reactive, what is the definition of a displacement reaction is more reactive metals displaces a less reactive metal. This is called displacement reaction. Okay, this is the basic definition of displacement reactions. For example, iron reacts with copper sulfate. Iron reacts with copper sulfate and gives iron sulfate and copper. Here iron is more reactive than copper. Okay, so that's why iron is easily replaces the copper. So this is the example of displacement reaction. Next, seventh property is corrosion. Corrosion means formation of rust is nothing but corrosion process. So how the rust is formed in metals? Metal slowly reacts with air and moisture present in the atmosphere. It get damaged and form a iron is called the corrosion process. Okay, so this process, the formation of rust is called the corrosion process. Only metals, only in metals, the corrosion process is takes place only in metals. Here I want to give you with the example of corrosion process. Here iron reacts with oxygen and water to give rust, to form rust. So you have to balance the equation also. Iron oxide, this is the rust. This is about the corrosion process. So it's all about the chemical properties of metals. Next, coming to the chemical properties of non-metals. Are very Very easy. The chemical properties of nonmetals are, the first chemical property is reaction of nonmetals with acids. Is the nonmetals reacts with acid? No. Nonmetals does not react with acids. Why? Because nonmetals are not soluble in acids. Next, reaction of nonmetals with bases. Some nonmetals are reacts with strong bases to form salts. Some nonmetals are reacts with strong bases to form salts. For example, chlorine is a nonmetal react with strong base NaOH and form NaCl, salt, NaClO and hydrogen gas. This is the example reaction of nonmetal with bases. And another one is sulfur reacts with NaOH to give sodium sulfate and water molecule. Next, third chemical property, reaction with oxygen. Reaction of nonmetals with oxygen. When the nonmetals reacts with oxygen to form nonmetal oxides. When the nonmetals reacts with oxygen to form nonmetal oxides, these are acidic in nature. For example, carbon is the nonmetal. We have to take carbon. Carbon is the nonmetal. Carbon reacts with oxygen to form carbon dioxide. Sulfur reacts with oxygen to form sulfur dioxide. Phosphorus reacts with oxygen to form phosphorus pentoxide. These are the basic examples of reaction of nonmetals with oxygen. Next, fourth chemical property. So before going into the fourth property, so all these products, that means these non-metal oxides, that means CO2, SO2, P4O10, these are dissolves in water to give acids. To give acids. Next, fourth chemical property, reaction of nonmetals with water. Nonmetals does not react with water. Why? Because these are insoluble in water. All the nonmetals does not react with water. These are insoluble in water. Fifth chemical property, formation of acidic oxide. When the nonmetals when the nonmetals reacts with oxygen to produce nonmetal oxides. So these nonmetal oxides reacts with water to produce acidic oxides like carbonic acid H2CO3. If CO2 reacts with water to form carbonic acid H2CO3, SO3 reacts with water to form sulfuric acid. So these are the acidic oxides. So next, final chemical property, formation of negative ion. When the nonmetal when the nonmetal gain an electron to form negative ion, or anion. For example, if chlorine, if we take chlorine as an example, chlorine have the capacity to gain one electron. So chlorine gain one electron and form chloride ion. This is the anion. The element which have negative charge is called the anions. This is all about the physical and chemical properties of metals and non-metals. So please read 1 to 2 times. You have a good idea about this topic. This is a basic and fundamental topic. If you have any doubts regarding this topic, please ask in comment section. So thank you for watching, guys.